Hello. Welcome to this calming journey through the universe. Tonight, we will explore the cosmos together in a slow, gentle way. Let yourself relax. Feel the weight of the day. Drift away. As you listen, we'll visit planets, stars, black holes, and distant galaxies. Softly, we'll travel through space, one fact at a time. So find a comfortable position, take a deep breath, and let's begin our journey through the infinite wonders of the universe. Let's start close to home in our solar system. The Sun, the star at the center, contains 99.8% of the solar system's mass. Its core is 15 million degrees Celsius, hotter than any furnace on Earth. Every second, the Sun produces more energy than humans have ever used in all of history. Mercury, the smallest planet closest to the Sun, has temperatures swinging from -173 to 427 degrees Celsius. Venus, often called Earth's twin, is shrouded in thick clouds made of sulfuric acid. Its surface is hotter than Mercury because of a runaway greenhouse effect. Earth, our home, has a unique feature: liquid water on its surface. Water covers about 71% of our planet. The Moon, Earth's only natural satellite, influences tides and has been visited by 12 humans. Mars, the red planet, has the tallest volcano, Olympus Mons. It's nearly 3 times taller than Mount Everest. Jupiter, the gas giant, has a storm called the Great Red Spot that's been raging for over 350 years. Saturn, famous for its rings, has over 80 moons. Uranus rolls around the Sun almost like a barrel on its side. Neptune, furthest from the Sun, has supersonic winds, reaching 2,100 kilometers per hour. Let's move farther, beyond our solar system, to the stars. Stars are massive spheres of gas, mostly hydrogen and helium. They shine because of nuclear fusion, turning hydrogen into helium, releasing immense energy. Some stars are small and dim, called red dwarfs. Others are huge and bright, blue giants, burning millions of times faster than our Sun. A supernova is when a massive star reaches the end of its life and explodes. The explosion can outshine an entire galaxy for a short time. Galaxies are massive collections of stars, dust, and dark matter. The Milky Way, our galaxy, contains over 100 billion stars, and there are billions of other galaxies. In the observable universe, some galaxies collide, merging slowly over millions of years, creating new stars. In a cosmic dance, the universe is about 13.8 billion years old. Light from distant galaxies takes billions of years to reach us. So when we look into space, we are also looking back in time. Every star we see tells a story from the past. Now, let's venture into the mysterious regions of space. Black holes are formed when massive stars collapse under their own gravity. Their gravity is so strong that not even light can escape. The edge of a black hole is called the event horizon. Nothing that crosses it can return. Inside, a singularity where space and time are infinitely curved. Neutron stars are smaller than black holes, yet extremely dense. A teaspoon of neutron star material would weigh about 1 billion tons. Some spin hundreds of times per second, emitting beams of radiation. These are called pulsars, and they can act like cosmic lighthouses, sending signals across space. Beyond our solar system, there are exoplanets, planets orbiting other stars. Some are hot, gas giants, hugging their stars. Others may be rocky, like Earth. Astronomers look for planets in the habitable zone where liquid water could exist. Kepler 452b is sometimes called Earth's cousin. It's 1,400 light-years away. Some planets may have exotic conditions, diamond rain on Neptune-like planets, or oceans of molten lava on planets orbiting very close to their stars. Each discovery teaches us how diverse the universe truly is. Space is full of incredible phenomena. Auroras on Earth are caused by charged particles from the sun colliding with our atmosphere. Comets are icy visitors traveling from the outer solar system. Their tails glow as they approach the sun. Meteors are space rocks burning up in our atmosphere. Meteorites make it to the surface as tiny gifts from space. Cosmic microwave background is the leftover radiation from the Big Bang. It tells us how the universe began. Dark matter makes up most of the universe's mass, yet we cannot see it directly. We only detect it by observing how it affects visible matter. Humans have always dreamed of reaching the stars. The first human in space was Yuri Gagarin in 1961. Since then, astronauts have walked on the moon, explored Mars with robots. The International Space Station orbits Earth every 90 minutes. Astronauts experience microgravity floating effortlessly. We have sent probes to every planet in the solar system. Voyager 1 is the farthest human-made object, leaving the solar system. Private companies now plan to take humans further into space. Mars colonization may happen in the coming decades, and each mission teaches us more about life beyond Earth. Let's end our journey with quiet reflection. Imagine drifting among the stars, the universe, vast, infinite, mysterious. Every star, every planet, every galaxy has a story. And we are part of this cosmic tapestry. Breathe slowly, feel the vastness of space around you. The largest known structure in the universe, the Hercules Corona Borealis Great Wall, stretches across more than 10 billion light-years. Space is expanding faster than the speed of light, not because objects move through space that fast, but because space itself is stretching. There are clouds of alcohol in space, including a massive cloud near the center of the Milky Way, containing enough ethanol to fill trillions of bottles. Black holes can warp time so intensely that minutes near their edge could equal years far away, making time itself bend under gravity. The moon is slowly drifting away from Earth at about 3.8 centimeters per year, making Earth's days gradually longer. Saturn's density is low enough that it could float in a giant bathtub of water, if such a bathtub could exist. Some stars are called blue stragglers because they appear younger than their neighbors, likely rejuvenated by stealing material from nearby stars. There are cold spots in space, colder than anything found naturally on Earth, including regions only a fraction of a degree above absolute zero. The largest volcano in the solar system, Olympus Mons on Mars, is nearly 3 times taller than Mount Everest and wide enough to cover an entire country. Jupiter's magnetic field is the strongest of any planet, stretching millions of kilometers into space and trapping intense radiation. Some meteorites found on Earth originated from Mars, blasted into space by ancient impacts, before landing here millions of years later. The Milky Way and Andromeda galaxies are moving toward each other and will merge in about 4 billion years, forming a new galaxy. There are planets made mostly of diamond, formed from carbon-rich interiors under immense pressure, creating worlds of crystal. The universe is not only expanding, it is accelerating, driven by dark energy, quietly pushing galaxies farther apart into endless space. There are more possible games of chess than atoms in the observable universe. A number called the Shannon number, showing how vast both logic and space can be. A single bolt of lightning on Earth contains more energy than a small nuclear explosion. Yet the Sun releases that amount of energy millions of times every second. Some stars pulse rhythmically, growing brighter and dimmer like slow cosmic heartbeats, helping astronomers measure distances across space. The largest known star, UY Scuti, is so big that if placed where our Sun is, it would engulf the orbit of Jupiter. Space has a faint smell, described by astronauts as metallic, like hot metal or welding fumes, caused by ionized particles clinging to their suits. There are regions of space where it rains diamonds, especially inside ice giant planets like Neptune and Uranus, where pressure turns carbon into crystals. A day on Mercury lasts longer than its year because it rotates slowly while orbiting the Sun quickly, creating extreme temperature changes. The Great Red Spot on Jupiter is a storm larger than Earth that has been raging continuously for over 350 years. Some galaxies contain almost no dark matter, challenging scientists to rethink how galaxies form and evolve. The coldest place in the known universe is the Boomerang Nebula, where temperatures drop below that of outer space itself. Astronauts grow taller in space because the spine stretches without gravity compressing it, sometimes by several centimeters. There are mountains on Pluto, made entirely of water ice, rising like frozen skyscrapers above its surface. The Sun will one day shed its outer layers, forming a glowing planetary nebula, leaving behind a white dwarf at its center. There are stars that explode more than once, known as recurrent novae, erupting repeatedly over centuries. The universe contains more stars than there are grains of sand on all the beaches on Earth, an unimaginable number of suns. There are rogue planets drifting through space, unattached to any star, wandering the galaxy in darkness. Some black holes spin so fast that space itself is dragged around them in a phenomenon called frame dragging. The Milky Way is rotating, but slowly, taking about 230 million years for our Sun to complete one orbit. Light from the Sun takes about 8 minutes to reach Earth, meaning you always see the Sun as it was 8 minutes ago. The universe may be infinite, with no edge, no center, just endless space extending in all directions. The Sun accounts for about 99.8% of the total mass of the entire solar system, making everything else feel almost weightless in comparison. If two pieces of metal touched in space, they would permanently stick together because there is no air or moisture to separate them. Some stars are so dense that light bends noticeably as it passes by them, creating a phenomenon called gravitational lensing. The Milky Way is estimated to contain between 100 and 400 billion stars, and possibly even more planets. There are clouds in space made of formaldehyde, large enough to preserve every human on Earth, in theory. Venus spins backward compared to most planets, meaning the Sun rises in the west and sets in the east there. A year on Pluto lasts 248 Earth years. So Pluto has not even completed one full orbit since it was discovered in 1930. Neutron stars can rotate more than 700 times per second, making them some of the fastest spinning objects in the universe. Some galaxies are shaped like rings, with bright outer edges and empty centers, creating glowing cosmic halos. The Sun produces enough energy in 1 second to power Earth for hundreds of thousands of years. The human body contains atoms that were once inside ancient stars, meaning every person is made of stardust. There are storms on Saturn that can wrap around the entire planet, forming massive hexagonal cloud patterns, the largest canyon in the solar system. Valles Marineris on Mars is over 4,000 kilometers long and up to 7 kilometers deep. Some stars are called hypergiants and lose mass so rapidly that they can shed an entire sun's worth of material in a single year. Space is not completely silent. It is filled with electromagnetic waves that can be converted into sound. There are moons that orbit in opposite directions, called retrograde orbits, defying the motion of most celestial bodies. Jupiter has more moons than any other planet, with over 90 confirmed satellites and counting. Some black holes emit faint radiation, known as Hawking radiation, slowly losing mass over immense periods of time. There are planets with glass rain, where molten glass shards fall sideways due to extreme winds. The universe is about 13.8 billion years old, yet it may continue existing for trillions or even infinitely longer. Some stars are born in clusters so dense that night skies on nearby planets would appear permanently lit. There are stars called red dwarfs that can live for trillions of years, far longer than the current age of the universe. The Moon has moonquakes caused by tidal forces from Earth and temperature changes. Some asteroids are actually loose piles of rubble, held together only by weak gravity. The Sun's core is about 15 million degrees Celsius, while its surface is only about 5,500 degrees. There are planets so close to their stars that their atmospheres are being stripped away into space. Some galaxies are cannibal galaxies, slowly absorbing smaller galaxies over billions of years. The universe may contain cosmic strings, hypothetical defects in space-time left over from the early universe. The Sun's light pressure is strong enough to push comet tails away from it, regardless of their direction of travel. There are stars that suddenly disappear, possibly collapsing directly into black holes without an explosion. Some planets experience seasons caused not by tilt, but by extreme orbital shape. The Milky Way contains vast clouds of molecular hydrogen, forming the raw material for new stars. The Sun completes one rotation about every 25 days at its equator, and slower near its poles. There are galaxies with almost no stars, composed mostly of dark matter. Light from the most distant galaxies we observe today began its journey shortly after the universe was born. Some moons have atmospheres thicker than Earth's, like Titan, Saturn's largest moon. The universe contains voids so large that thousands of galaxies could fit inside them. Space-time can ripple, like water, when massive objects collide, creating gravitational waves. The laws of physics appear the same everywhere in the universe, suggesting a deep cosmic unity. The universe began with the Big Bang, a moment when space, time, and energy came into existence. Not an explosion in space, but an expansion of space itself. In the first seconds, the universe was extremely hot and dense. As it expanded, it cooled, allowing particles to form. Hydrogen and helium were the first elements created. Over millions of years, gravity pulled matter together, forming the first stars and galaxies. Everything we see today traces back to that first moment, a quiet beginning to an infinite story. The first stars, called Population 3 stars, were massive, hot, and short-lived. They formed from pure hydrogen and helium, with no heavier elements. These stars burned quickly and exploded, creating the first metals like carbon, oxygen, and iron. Their explosions seeded the universe with building blocks for planets, life, and even you. Though we have never seen them, their legacy lives in every star and every atom today. Our galaxy, the Milky Way, is a spiral galaxy with sweeping arms filled with stars, gas, and dust. At the center lies a supermassive black hole called Sagittarius A star. It holds the mass of 4 million suns. Galaxies come in many shapes: spiral, elliptical, irregular. Some collide and merge. Others drift alone in quiet space. Each one a universe of its own. Stars often form together in clusters. Open clusters are young and loosely bound. Globular clusters are ancient, dense, and spherical. Some globular clusters contain stars over 12 billion years old. They orbit galaxies like cosmic lanterns, preserving the earliest history of the universe. Each cluster is a family of stars born together, drifting through time. Many stars are not alone. They orbit with companions in binary systems. Some systems contain 3, 4, or even more stars. Stars can exchange matter, pulling gas from one another. This can cause dramatic explosions called novae, or powerful supernovae. Planets can orbit 2 suns, creating skies with double sunsets. A gentle reminder that the universe is more creative than fiction. Space may not be flat. It could be curved or folded, like the surface of a sphere or a saddle. We measure the shape of the universe by observing light from distant galaxies. So far, it appears nearly flat, but still infinite and expanding. The true shape of space remains a cosmic mystery, quiet, vast, and endlessly fascinating. Shortly after the Big Bang, the universe expanded extremely fast. In a fraction of a second, it grew exponentially. This process is called inflation. It smoothed the universe, making it nearly uniform. And it explains why distant regions look similar. Inflation happened long ago, but its effects shape everything we see today. A silent burst that shaped eternity. Galaxies are not scattered randomly. They form a vast structure called the cosmic web. Filaments of galaxies stretch across space. Between these filaments are enormous voids, almost empty. regions. This structure looks like a giant, three-dimensional web spanning the universe. Matter flows along these filaments, feeding galaxies and shaping cosmic evolution. Galaxy clusters group together into superclusters, the largest structures known in the universe. One of them, called Laniakea, contains our Milky Way and thousands of other galaxies. These superclusters move together, pulled by gravity toward regions of immense mass. They reveal how matter organizes itself on the grandest scales. There is a limit to how far we can see. This boundary is called the observable universe. Beyond it, light has not yet reached us. As time passes, more of the universe becomes visible. Yet, some regions may forever remain beyond reach, quiet, distant, unreachable like whispers, carried on cosmic winds. What will happen to the universe in the end? One possibility is the Big Freeze, where galaxies drift apart, stars burn out, and the universe becomes dark and cold. Another is the Big Crunch, where gravity pulls everything back together, or the Big Rip, where expansion tears everything apart. The future of the universe remains unknown, but its story continues, quietly unfolding. Space is often called empty, but it is not truly nothing. Even in the vacuum, particles appear and disappear. This is called quantum fluctuation. Energy briefly pops into existence, then fades away. Even emptiness has structure, and silence carries invisible motion. The universe hums softly, even in its quietest places. Cosmic dust is made of tiny particles, carbon, silicates, ice, and metals. Though small, it plays a powerful role. Dust blocks light, shapes nebulae, and helps form stars and planets. It creates beautiful dark cloud and glowing regions. Dust is both creator and concealer, soft, drifting through the universe. Nebulae are stellar nurseries where gas and dust collapse under gravity, forming new stars. The Orion Nebula is one of the closest and most studied star-forming regions. Inside, hundreds of young stars shine. Some stars form alone, others in clusters. Each birth lights another candle in the cosmic dark. Planets do not always stay where they form. Some migrate inward or outward, pulled by gravity from other planets, or the disk of gas. Hot Jupiters are gas giants that orbit very close to their stars. They likely formed far away and moved inward. Planetary systems are dynamic, shifting, evolving. Nothing in space is truly still. Everything in space is in motion. Planets orbit stars, moons orbit planets, stars orbit galactic centers. Orbits can be circular or elliptical. Some objects wobble or precess. Gravity choreographs a cosmic dance, smooth, rhythmic, endless, a quiet ballet across the universe. Gravity stretches and squeezes objects. These effects are called tidal forces. They cause ocean tides on Earth and volcanoes on Jupiter's moon. Io, near black holes, tidal forces become extreme, stretching objects into long strands, a process sometimes called spaghettification, a strange yet fascinating cosmic effect. The universe follows patterns and symmetry. Spirals appear in galaxies, hurricanes, and seashells. Mathematical laws shape cosmic structures, even subatomic particles, follow symmetrical rules. Broken symmetry creates diversity and complexity. From chaos emerges beauty, and from simplicity arises the cosmos. Traveling between stars is one of humanity's greatest challenges. Even at light speed, it would take years to reach nearby systems. Concepts like generation ships, cryogenic sleep, and warp drives have been imagined, though currently beyond our technology. Robotic probes may one day explore distant systems, carrying humanity's curiosity across the stars. A quiet, slow journey through eternity. As we rest beneath the stars, let the universe feel close and gentle. Every atom in your body once belonged to a star. You are part of the cosmos, not separate, not small, but woven into the fabric of space and time. Breathe slowly, feel the stillness. Let the universe cradle your thoughts and carry you into peaceful sleep. Far from stars and galaxies, there are regions of deep space, almost empty. No light, no sound, only vast distance. These voids stretch millions of light years. Yet even here, particles drift slowly. Nothing is truly alone. Silence itself becomes a presence. The universe is filled with color. Nebulae glow in reds, blues, greens, and golds. Each color reveals a different element. Red shows hydrogen. Blue reveals oxygen. Green often marks ionized oxygen. Purple blends hydrogen and oxygen together. These colors are invisible to the naked eye, but telescopes reveal their hidden beauty. When massive objects collide, they send ripples through space-time. These ripples are called gravitational waves, first detected in 2015. They confirmed a prediction by Einstein made over 100 years earlier. These waves allow us to listen to the universe, to hear black holes and neutron stars collide in silent, cosmic echoes. The universe is a balance between expansion and gravity, between energy and matter. Too much gravity, and the universe would collapse. Too much expansion, and stars would never form. This delicate balance allows complexity, life, and beauty, a quiet harmony woven into existence. Light carries information across the universe. Its color, brightness, and spectrum tell us what stars are made of, how hot they are, how fast they're moving. Astronomers read light like a cosmic language. Each wavelength, a word, each spectrum, a sentence, describing the story of distant worlds. Ice exists throughout space. Frozen water, methane, ammonia, carbon dioxide, coating dust grains and comet cores. Ice helps molecules stick together, forming complex compounds, some of which may lead to life. Comets deliver ice to planets, possibly bringing water to early Earth, a quiet gift from the cold depths of space. These paths are stable, rhythmic, predictable. Yet over time, they slowly change, shaped by distant forces and tiny nudges, a slow, endless dance across space. Space has storms too. Solar storms erupt from the sun, sending charged particles toward Earth. Jupiter has storms larger than Earth itself, spinning for centuries. Neptune hosts supersonic winds sweeping across frozen clouds. These storms remind us that space is dynamic, alive, and powerful. At the center of most galaxies lies a black hole, millions or billions of times more massive than the Sun. These black holes shape their galaxies, regulating star formation, controlling gas flow, and anchoring cosmic structure. Though invisible, they are architects of the universe. Dust lanes weave through galaxies, dark ribbons blocking starlight, shaping spiral arms and nebulae. They mark regions where stars are forming and where planets may one day arise. Dust, soft, silent, drifting, the seeds of future worlds. Between galaxies lies intergalactic space, a vast ocean of near emptiness, yet faint gas still drifts between stars. This space carries the echoes of cosmic history, matter stretched thin across unimaginable distance, a quiet bridge between galaxies. Cosmic dawn marks the time when the first stars ignited, ending the universe's dark ages, lighting up the cosmos for the first time. These first lights changed everything, heating gas, shaping galaxies, creating the foundation for all cosmic structure, a gentle sunrise across eternity. Stars vary greatly in mass. Some are tiny red dwarfs, others are massive blue giants. Mass determines how a star lives, how long it shines, and how it dies. Small stars burn slowly for trillions of years. Large stars burn quickly and explode. Each mass follows a different destiny. Some planets are surrounded by magnetic fields. These fields protect atmospheres, deflecting harmful radiation. Earth's magnetosphere shields us from solar wind. Jupiter's magnetosphere is the largest structure in the solar system. Magnetic fields create auroras and shape planetary environments, invisible yet powerful, guardians of worlds. In one possible future, the universe will reach heat death, where energy is evenly distributed and no more work can be done. Stars will fade, galaxies will darken, matter will slowly decay. Time will continue, but change will cease. A quiet ending to a vibrant story. Shadows exist in space too, where stars are blocked by dust or planets. These shadows create dark nebulae and silhouettes. Against glowing gas, eclipses are cosmic shadows in motion. Brief, beautiful moments of alignment, light and dark dancing across the sky. Molecules essential for life, like amino acids and sugars, have been found in space. They form on icy dust grains in cold clouds between stars. Comets and asteroids may deliver these molecules to planets, seeding the potential for life across the cosmos. Stars constantly release streams of particles called stellar winds. These winds shape nebulae, strip atmospheres, and sculpt planetary systems. The sun's wind interacts with Earth's magnetosphere, creating auroras and space weather. Stellar winds are gentle yet powerful, breaths of the cosmos. Between stars lies silence, vast, still, endless. Yet within this silence, particles drift, light travels, time passes. Silence is not emptiness, it is space, waiting, holding potential, motion and memory, a quiet canvas for cosmic art. Nebulae glow softly in the darkness of space. These clouds of gas and dust are illuminated by nearby stars, creating gentle waves of color across the cosmos. Some nebulae are places where new stars are born, while others are the remains of stars that have ended their lives. Each nebula tells a quiet story of creation and transformation, drifting peacefully through the galaxy. The universe moves in steady rhythms, stars pulse, planets orbit, and galaxies rotate. Nothing in space is truly still. Even the smallest particles vibrate with energy. These rhythms create a cosmic harmony, a gentle heartbeat, echoing across billions of light years, inviting you to slow down and breathe with the universe. Light from distant stars travels for millions, or even billions of years before reaching your eyes. Some of the stars you see tonight may no longer exist, yet their light continues its journey through space. Each tiny point of light carries a message from the past, quietly whispering across time. Orbits are the graceful paths that celestial bodies follow. Planets move around stars, moons glide around planets, and stars drift around the centers of galaxies. These paths are shaped by gravity, creating smooth, predictable motion. Over time, orbits shift gently, adapting to subtle changes in the universe. Most of space is extremely cold, close to absolute zero. Without nearby stars, there is almost no heat. Yet in this cold, molecules form and clouds gather, preparing the ingredients for new stars and planets. Even in freezing darkness, the universe continues its slow, quiet creation. In orbit, everything floats, free from weight. Astronauts drift gently through spacecraft, water forms glowing spheres, and movement becomes slow and graceful. This weightlessness reveals how gravity shapes our lives and how different existence feels. When gravity loosens its hold, stars release steady streams of particles, known as stellar winds. These winds flow outward, shaping nebulae, carving cosmic structures, and influencing nearby planets. The universe breathes through its stars, exhaling energy into the vastness of space. Between galaxies lie immense distances, filled with near silence. Here, only faint gas drifts, slowly through the darkness. Light travels freely across millions of light years, connecting distant islands of stars. The space between galaxies feels empty, yet still alive with motion and possibility. Planets form, slowly, from disks of dust and gas around young stars. Tiny grains collide, sticking together, growing into rocks, then worlds. Over millions of years, gravity sculpts these bodies, shaping mountains, oceans, and atmospheres. Each planet is a patient creation of time and motion. The night sky appears still, but it is always moving. Earth spins, stars drift, planets wander, and galaxies rotate. Every moment, the sky is different, though the change is subtle, gentle, and continuous. The universe flows, even when we stand still. Cosmic dust drifts softly between stars, forming clouds, blocking light and nurturing new stars. Though each grain is tiny, together they shape galaxies, color nebulae, and seed planets. Dust is the quiet architect of the universe. When stars near the end of their lives, they glow softly, shedding their outer layers into space. These glowing shells form planetary nebulae, creating delicate shapes and luminous colors. The death of a star becomes a final gift of beauty and matter to the cosmos. Gravity acts silently, shaping everything. It pulls planets into orbits, gathers gas into stars, and bends light itself. Though invisible, its influence is everywhere, guiding motion, creating structure, and holding the universe together in quiet balance. Starlight carries information about temperature, motion, composition, and age. Astronomers decode this light like a cosmic language. Each color shift, each spectral line tells a story of distant suns, ancient galaxies, and unseen worlds. Time in the universe moves differently than on Earth. Stars live for billions of years. Galaxies evolve over eons, and even light takes time to cross space. The universe unfolds, slowly, patiently, measuring existence in vast scales beyond human life. All of space is filled with a faint glow, left over from the birth of the universe. This cosmic background radiation is the echo of the Big Bang, quietly bathing everything in gentle energy, reminding us of the universe's first light. Planets glide smoothly through space, following curved paths shaped by gravity. Their motion is steady, predictable, and calming. Orbit after orbit, they repeat their journeys, creating rhythms that last for billions of years. Dark energy fills the universe, driving its expansion outward, faster and faster. We cannot see it or touch it, yet it shapes the fate of everything. It is a quiet force, pushing galaxies apart in a slow, cosmic breath. Between stars, and there is stillness, vast, gentle, and deep. Here, light travels undisturbed, particles drift slowly, and silence feels infinite. This stillness is not empty, but full of quiet motion and unseen energy. Imagine drifting gently among the stars, weightless, calm, and unhurried. Galaxies glow softly in the distance. Stars shimmer quietly around you. The universe holds you in peaceful motion as you rest in its endless embrace. The universe contains more galaxies than there are grains of sand on Earth. Each galaxy holds billions or even trillions of stars, and around many of those stars orbit unseen worlds. A single day on Venus is longer than a year on Venus because it rotates so slowly, while orbiting the Sun relatively quickly. Neutron stars are so dense that 1 teaspoon of their material would weigh more than Mount Everest. Yet they spin hundreds of times per second. The Sun converts about 4 million tons of mass into energy every second, releasing light and heat that travel across space to warm our planet. There are rivers of stars called stellar streams, left behind when small galaxies are torn apart by larger ones, drifting through space like cosmic currents. Some planets orbit 2 stars at once, creating skies with double sunsets and complex seasons. The Moon has many mysteries. Its surface is covered in fine dust called regolith. Craters record billions of years of cosmic impacts. The Moon influences our tides, and ancient civilizations used it to mark time. Lunar rocks brought back by astronauts tell us about Earth's past. The far side of the Moon looks very different. Mountains and basins shaped over eons. Its quiet beauty has inspired poets and dreamers for centuries. Our Sun is the center of life on Earth. It's a medium-sized star, but it gives enormous energy. Solar flares sometimes erupt from its surface, sending particles that create auroras on Earth. Sunspots are cooler regions. On the Sun, they appear dark against the blazing surface. The Sun will eventually become a red giant, expanding and engulfing the inner planets. But this will not happen for billions of years. For now, we bask in its gentle warmth. Every planet has its own atmosphere. Earth's protects and sustains life. Venus is thick, hot, and poisonous. While Mars is thin, mostly carbon dioxide, Jupiter and Saturn have no solid surface. Their atmospheres are made of hydrogen and helium. Uranus and Neptune have winds, reaching thousands of kilometers per hour. Atmospheres shape weather, storms, and climate. They also protect planets from harmful radiation. Even tiny changes in a planet's atmosphere can drastically affect life. Asteroids are rocky remnants from the solar system's formation. Some orbit between Mars and Jupiter. In the asteroid belt, comets are icy and develop glowing tails. As they approach the Sun, Halley's Comet returns every 76 years. Asteroids can impact planets, and scientists track them carefully to protect Earth. Meteor showers are caused when Earth passes through a comet's trail. And if you watch on a clear night, you might see a streak of light. Some planets wear rings like jewelry. Saturn's rings are the most famous, made of ice, rock, and dust. They are thin yet wide, stretching thousands of kilometers. Jupiter, Uranus, and Neptune also have rings, though fainter and harder to see. Rings can form from broken moons or leftover debris from planetary formation. They shimmer under the Sun, creating delicate patterns. Some moons are icy, hidden oceans lie beneath their surfaces. Europa, Jupiter's moon. Exploring these moons is like looking into another Earth. Space is often called silent, but in truth, it is filled with vibrations. Plasma waves oscillate in magnetic fields. Gravitational waves ripple across the universe. Some radio telescopes capture the echoes of distant pulsars. We can listen to black holes indirectly. These cosmic sounds are slow, haunting, beautiful. They remind us that space is alive in its own way. Telescopes let us peer into distant worlds. The Hubble Space Telescope has captured breathtaking images of nebulae, galaxies, and star clusters. The James Webb Space Telescope looks even deeper. Infrared light reveals hidden stars and early galaxies. Observatories on Earth complement space telescopes. Together, they expand our understanding of the universe. Every image tells a story, billions of years old, and reminds us how much we can discover when we look carefully. The universe is constantly expanding. Galaxies drift away from each other. The farther they are, the faster they move. This expansion is driven by dark energy. It accelerates over time. One day, galaxies may drift beyond our view, and the night sky will become emptier. Yet, knowing this also reminds us of the fleeting beauty of now. Humans have always looked up. Space inspires curiosity, wonder, and dreams. We imagine space travel, colonies on Mars, and contact with distant civilizations. Astronauts float in the void, experiencing freedom and silence. We continue to explore, sending probes and satellites. Every discovery teaches us more about the universe and ourselves. Space is the final frontier. It invites us to dream, to learn, to imagine, and to remember that we are part of something infinitely vast. Space is a realm of extremes. Mercury scorches at 430 degrees Celsius and plunges to minus 180 degrees at night. Venus is hotter than Mercury due to its thick atmosphere. The outer planets are icy, cold, far from the sun. Neptune averages minus 214 degrees Celsius. Even black holes can radiate tiny amounts of heat called Hawking radiation. Temperature in space is relative, depending on location and energy. Stars are born in clouds of gas called nebulae. Gravity pulls matter together, forming a protostar. As the core ignites, nuclear fusion begins. Stars spend most of their life as main sequence stars. Our Sun is currently in this stable phase. Massive stars become supernovae, exploding spectacularly. Small stars become white dwarfs, slowly fading. Neutron stars or black holes may form. Stars live, die, and recycle material into new stars. The cosmos is a never-ending cycle of creation and destruction. Distances in space are almost impossible to imagine. Light years are used to measure vast expanses. 1 light year is 9.46 trillion kilometers. The nearest star, Proxima Centauri, is 4.24 light years away. Our galaxy spans about 100,000 light years, and the Andromeda Galaxy is 2.5 million light years away. The universe keeps expanding faster and faster. Distance in space makes us feel small and curious. Some phenomena are visible even from Earth. Auroras light up the polar skies. Meteor showers streak across the night. Eclipses occur when one celestial body blocks another. Solar eclipses darken the daytime sky. Briefly, lunar eclipses cast a red glow on the moon. Supernovae and bright comets are rare, but they remind us the universe is alive, moving and changing. Watching these events connects us to the cosmos. The universe is more flexible than our minds can imagine. Time, space, energy all dance together. Are we alone in the universe? The question fascinates humans. For centuries, we search for planets with water and the right conditions. Microbes might exist on Mars or Europa. Europa, a moon of Jupiter, has an ocean beneath its icy surface. Enceladus, Saturn's moon, also hides water. Below ice, life could exist in forms we cannot even imagine. The universe may host countless civilizations. Some could be advanced far beyond our technology. We may never meet them, but imagining other life helps us explore the possibilities and appreciate our own fragile world even more. Space is full of incredible phenomena. Auroras on Earth are caused by charged particles from the sun colliding with our atmosphere. Comets are icy visitors traveling from the outer solar system. Their tails glow as they approach the sun. Meteors are space rocks burning up in our atmosphere. Meteorites make it to the surface as tiny gifts from space. Cosmic microwave background is the leftover radiation from the Big Bang. It tells us how the universe began. Dark matter makes up most of the universe's mass. Yet, we cannot see it directly. We only detect it by observing how it affects visible matter. Humans have always dreamed of reaching the stars. The first human in space was Yuri Gagarin in 1961. Since then, astronauts have walked on the moon, explored Mars with robots. The International Space Station orbits Earth every 90 minutes. Astronauts experience microgravity, floating effortlessly. We have sent probes to every planet in the solar system. Voyager 1 is the farthest human-made object leaving the solar system. Private companies now plan to take humans further into space. Mars colonization may happen in the coming decades. And each mission teaches us more about life beyond Earth. Let's end our journey with quiet reflection. Imagine drifting among the stars, the universe, vast, infinite, mysterious. Every star, every planet, every galaxy has a story, and we are part of this cosmic tapestry. Breathe slowly, feel the vastness of space around you. You are small yet connected to something unimaginably grand. As you rest, let the universe whisper its secrets to you. Thank you for joining me on this relaxing journey. Subscribe to Sleepy Calm Facts for more calming videos to help you drift into a deep, peaceful sleep.